Okay, let's dive into this. Welcome to today's Explainer. We are looking at a snapshot of the tech world as it stands right now. And let me tell you, it is an incredibly weird time to be alive. I mean, it's only April of 2026, and already the landscape is completely flooded with what some are calling revolutionary new tech and what others might just call pure, unadulterated chaos. We're going to break down the absolute most impactful software release of the year, but first, we need to set the stage by looking at the chaotic hardware environment it was born into. Just look at the incredibly specific consumer electronics that have hit the market this year. We have a $400 AI-enabled smart toilet that comes fully equipped with a microphone and a 2-megapixel camera. Why? So you can know exactly how many Taco Bell Diablo-dusted chicken nuggets you can safely consume before your gut microbiome effectively unalives itself. Then there are the AI-enabled smart clippers, relying on Claude to go full Sweeney Todd on your hair so you can avoid the Dario Eagle's Nest look. And of course, the AI Pocket Pet. You can feed it, bathe it, and play with it, but the real feature is getting to hear it actively beg for its life as it fakes sentience right before dying of starvation. It is a bleak, hyper-specific hardware landscape. Section 1. The rise of OpenClaw. But hardware is honestly just a distraction from what's really happening over in the software space right now. The undisputed ringleader of that space is OpenClaw. We can trace its incredibly rapid and totally chaotic ascent right here. OpenClaw was officially released back in January, and almost immediately, the fervor around running this software locally triggered a literal nationwide shortage of Mac Minis. People were literally hoarding hardware just to run it. Fast forward just a few months to April, and the project's creator, Peter Steinberger, is already doing an elite European speaking tour. He's telling OpenClaw's origin story to a room full of elites at TED, and then pivoting to discuss fixing its massive security vulnerabilities to a room full of engineers at AI Engineer Europe. Now, what's really interesting about this slide is the sheer gravity of the praise OpenClaw is receiving from the very top of the tech food chain, despite its really rough edges. The interest chart for this project is highly volatile, sure, but as former GitHub CEO Nat Friedman noted, pessimists sound smart, but optimists make money. And nobody is more optimistic than NVIDIA CEO Jensen Huang. He actually went on record calling OpenClaw, quote, the single most important release of software probably ever. That is incredibly high praise for a project with an absolute massive amount of security vulnerabilities. And the wild thing is, the reason for this massive adoption isn't just elite engineers, it's everyday, non-technical users. Think about it. In the past, people flexed by buying a token on a blockchain, pointing to a JPEG monkey on a private server that eventually shut down, right? Well, today, the new status symbol is flexing how many tokens it takes to automate literally any mild inconvenience in your life. Sick of reading emails you're actually paid to read? Users just throw tokens at the OpenClaw email summary skill. Can't figure out your nutrition? They fire up the diet tracker skill. Dealing with erectile dysfunction? Yes, people are quite literally trying to rub some tokens on it using OpenClaw. But automating your life comes with a massive cost. 1,100. That is the staggering total number of security advisories the OpenClaw project has received since its launch. Remember, this software completely lacks basic security, which is exactly why it has been an absolute nightmare for the team to maintain. However, when we contrast that massive pile of security alerts with this next number, the reality of the situation becomes a whole lot clearer. Out of those 1,100 advisories, only about 650 of them have actually been resolved or closed by Peter and the development team. So it kind of begs the question, what exactly is happening to the remaining hundreds of security tickets flooding the system? So the crucial point is how Peter filters out all that noise. He categorizes the remaining tickets as slop issues. His filtering system is brilliantly cynical. Anytime a security report is too nice, or the person submitting it apologizes, he just completely ignores it. Why? Because that level of politeness is a dead giveaway that the ticket is AI generated. As Peter notes, real people working in security simply do not apologize. It's a hilarious yet highly effective way to manage an overwhelming queue of fake tickets. Section 2. The family tech support problem. Let's bring all this chaotic tech down to a highly relatable personal level. If you work in tech, you know the drill. Your relatives automatically assume you know how to fix their printers or troubleshoot their Wi-Fi. It's a universal burden. But here's the thought. Can we leverage OpenClaw to handle all of these inbound family tech support requests for us? And more importantly, can we generate the responses in our own voice so they never even know they're talking to a machine? Let's engineer a solution to this. Section 3. Deploying on a VPS. To make this automated family avoidance system a reality, we first need to tackle the infrastructure. As we saw on the timeline earlier, the trendy method right now for indie hackers who are currently using OpenClaw to automate their unemployment applications is to buy a Mac Mini. But that triggers those nationwide hardware shortages and is frankly expensive. The much more practical route is using a virtual private server, or VPS, like the ones from Hostinger. It's just a few bucks a month, but critically, it runs everything in a private vault. This isolation means your AI agent won't accidentally leak embarrassing personal data to your family, like information about a very common medical condition that affects more than 30% of men worldwide. Privacy is absolutely key here. Setting this up requires a highly strategic deployment. First, we select the manual quick start option on the hosting platform. Next, we deploy the specific one-click OpenClaw plan directly into that private vault for maximum security. And finally, we'll need to securely SSH into the server to manually get under the hood and make our custom configuration changes. We are treating this family tech support bot with the exact same gravity as a highly complex enterprise software deployment, as we should. Section 4. Building the voice bot. With our server running, we move to the actual configuration of the bot itself, combining APIs to effectively clone a human presence. Out of the box, our server gives us config options, including a Telegram bot that's already partially wired up. To finish the connection, we first message the bot father on Telegram to create a new bot and generate a token. Step 2, we copy and paste that token ID directly into our server environment. And step 3, the really fun part, we edit the server files. As the creator notes, we basically play God to give our bot some purpose, and then we play alcohol to give it some personality. When we SSH into the server, we find where that personality is actually stored. It lives in a file absurdly named soul.md. This is a writable markdown file located right there on your server. This file is literally the soul of the machine. It's where you explicitly define the AI bot's specific attitude, tone, and the exact level of sarcasm it should use when explaining to a relative that their router is broken. But text isn't enough, right? We need our own voice. To generate responses in a cloned voice, we tap into 11 Labs, where a voice profile has already been created. Step 1 is adding the 11 Labs API key and voice ID into the server's environment file. Step 2 is crucial. Telegram voice memos require a specific format, so we use a tool called FFmpeg to automatically convert the MP3 audio from 11 Labs into an OGG voice memo file. Finally, we add a tools.mmd file, which gives OpenClaw the full context on how to string this entire pipeline together. And this brilliantly illustrates the complete technical architecture from receiving a text to spitting out an audio file. You can see how these components work in tandem. OpenClaw handles the raw text analysis, outputting a drafted text response based on that soul.md personality. Then 11 Labs takes over for voice generation, taking that text and spitting out an MP3 audio file in our exact voice. Finally, FFmpeg handles the format conversion, turning that MP3 into the final OGG voice remo ready to be sent. Because we put in all that complex wiring on the server, the final workflow for the end user, you, is incredibly, almost dangerously simple. Whenever a tech support request text comes in from a family member, you simply forward that message directly to your Telegram bot. The bot instantly analyzes the request, drafts the response, runs it through the Python script to generate the audio, and gives you back a voice memo. All you have to do is forward that resulting voice memo straight to Uncle Frank. And what does that final product actually sound like? Well, thanks to the personality we injected into the soul.md file, the bot spits out a perfectly dismissive, cloned audio response. It sounds exactly like this. Yeah, the internet is down because that router port is cooked. Unplug it and replace the router. Unless electrical fire was the plan. It's flawless. It solves the family member's problem while requiring absolutely zero emotional energy from you. Section 5, Emotional Detachment at Scale. Let's move to and see how this builds to its logical, highly cynical conclusion. Think about it. We've taken a controversial piece of software, deployed it securely, and chained it to voice synthesis tools just to avoid explaining Wi-Fi to our relatives. By simply forwarding a voice memo generated entirely by a machine, we arrive at the ultimate punchline of the OpenClaw era. We are utilizing cutting-edge AI to accomplish a deeply human avoidance strategy. Or, to put it perfectly, we are achieving what every computer programmer has always dreamed of, emotional detachment from your family at scale. It is a grand technological achievement born purely out of a desire to avoid mild frustration. We've seen how a few tokens and a messy AI assistant can fundamentally change how we interact or choose not to interact with the world around us. So I'll leave you with this to think about. Look around your own life. Look at the notifications on your phone and ask yourself, What mild inconvenience will you automate next to achieve your own emotional detachment? Thanks for joining me on this explainer, and I'll catch you on the next one.